Okay, so now we go to exercise 3.3.2 number 1. So by looking at the exercise, the claim, the hypothesis or the claim here, that is test the hypothesis, either the safety program is effective or not. Okay, this is very general statement. So effective, so we to choose the proper parameter that we need to use, we can look at the variable used for this data. The variable used, that is about average weekly losses of worker hours. Okay, so this is the variable. When we look at the variable here, okay, variable means that the data is about what? Okay, we can see that the suitable parameter is mean. Okay, so this is mu. So for this case, we want to look at mu, mean, and we have two data sets, data before and data after. So for this case, we need to be careful to choose the parameter. Either this is under the independent sample or dependent sample. Okay, to identify which one is suitable to the question, okay, we can observe the data. Okay, we can see that data before and data after are related to each other. Okay, because this is we look at the same plants. Okay, so that's why the suitable one is by using mu d. So mu d here. Okay, and as for d is the data difference here. We have two approaches here. Remember that d here, that we want to get, that is d for the effective. So d here can be effective for this case, that is before. Okay, look at the variable is losses of worker hours, average weekly losses of worker hours. So to show that the program is effective, meaning that data before should be greater than data after. Okay, or the second version, okay, that is data after less than data before. Okay, so because this is about the losses of worker hours, so for the first version of d, b greater than a, meaning that this is b minus a, the same as b minus a, greater than 0. The second version for d, that is a less than b, this is data a minus data b less than 0. So we can choose either version of d. Okay, so let's say we want to choose this version. So we want to choose this version. So mu d here is less than 0. Okay, okay, and this is the claim that we want to test. The claim here is the safety program is effective. Okay, so d here is defined as a minus b. Okay, so okay, so now when we identify the claim, so now the next step is we construct the hypothesis as usual. Okay, construct the hypothesis. Look at this one. This is less than. Look at the max expression here, less than. So since there is unequal sign here, so the hypothesis this is under H1. Okay, first step. So automatically, okay, H null here, that is mu D greater than or equals to 0. Okay, so complete step 1. For step 2, okay, remember that our D is A minus B. For step 2, okay, since our D here is A minus B, okay, step 2, we need to calculate T test. Okay, because for the mu D, for our course, we only consider for the case of population variance unknown and sample size small. So that's why we use T test. So T test here, so we need to get the data difference first. Okay, remember that our D is A minus B. So data A minus data B, data after minus data before. Okay, so we get the number of data here, and D here is equals to 10. Okay, X bar D and ST, by using calculator we get the values here. So after that, substitute the value of ND, X bar D and ST to the formula of T test and simplify the answer for decimal places. So complete step 2. So now we go to step 3. Step 3, we want to establish the test criterion. So the first factor is we need to look at the distribution used in step 2. This is T test. So we need to plot the distribution. Okay. So to identify the critical value, okay, so we can look at the inequality used in H1. That is less than. Less than meaning that the rejection region lies on the left tail of the T distribution, and no need to divide alpha by 2. Our alpha here is 0.05. So no need to divide our alpha by 2 since this is under one tail test. So by using statistical table, get the T 0.05 with a decrease of freedom 9. So we get this is the critical value here is negative 1.8331. So once we can get the rejection region and critical value, so complete step 3. So now go to step 4. Step 4, we want to make a decision on H null. So by comparing the value of T test in step 2 with the critical value in step 3, we can see that T test here lies on this area. Okay, means that to write this in a proper form, you can see that T test is greater than the critical value. This is the critical value. So since this is the T test greater than T critical value, okay, you can see that this is lies on the acceptance region. So the decision is do not reject H null. Do not reject H null, meaning that here do not reject H null, meaning that at alpha 0.05 we reject the claim. Okay, we reject the claim, so we can say that the safety program is not effective. So for other exercise, please do consult your lecturer. So that's all. Thank you.